Okay guys, so we just finished doing some integration. What we're going to do now is talk about summations. We like summations because they let me add a bunch of stuff at once. So we have to take a look at what that is. So the definition is the sum of n terms, a sub 1, comma, a sub 2, comma, dot, 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 comma, a sub n, is written as the summation from I is equal to 1 to n of a sub I is a sub 1 plus a sub 2 plus a sub 3 plus dot, 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 a sub n. Not done yet, just waiting for you to catch up. That's where I is the index of summation a sub I is the ith term of the sum, and the upper and lower bounds of summation are n and 1. So we enjoy sums because they allow me to add up a bunch of stuff at once. It deals with geometric series, which we've seen in geometry. Now we can go ahead and talk about finding them and dealing with them with calculus. So what I do is anytime I see an I replace it with the first value, and then I continue doing that, increasing each by 1 each time until I hit the top value. So in this example, I have the summation of I. So what I'm going to do is I'm going to replace I with 1, then the next number, which is 2, then 3, and 4, 5, and 6. I'm going to go ahead and add all of those together because that's what my summation tells me. And when I go ahead and add those, I end up getting 21. Sometimes we're given more complex summations, which again, I'm still going to start with the lowest bound, plug that in, and keep going until I get to the highest bound. So in this case, my lower bound starts with 0. So I have 0 plus 1, then I have 1 plus 1, then I have 2 plus 1, then I have 3 plus 1, then I have 4 plus 1, then I have 5 plus 1. Well, this gives me 1 plus 2 plus 3 plus 4 plus 5 plus 6, which ends up giving me the exact same number as the problem above, which again is 21. We can also do even more complex summations, like things squared. So even though my j and j are different than the i's I've seen, it still is referring to a summation. So as long as the lower bound matches whatever I'm asked to being added, I can plug things in. So my first value is 3, so I have 3 squared, plus 4 squared, plus 5 squared, plus 6 squared, plus 7 squared, which is 9, 16, 25, 36, plus 49, which gives me a whopping 135. I can also go the other way around. I have a glare somewhere here on my glasses, sorry. So I want to take a look at what is changing in each sum. So what part gets changed? Good, the number in parentheses. So I have a summation, and my initial I starts at, in this case, 1, and it looks like I go to 9. And that's a summation of of 1 over 4i. Because my 4 and whatever my term is are being multiplied together. All right, what's changing in this one? I have the summation from I is equal to 1, and my n in this case is going to be 18, and that's 6 over 2 plus I. All right, let's go ahead and look at one that's a little bit more complicated. So what part gets changed? Okay, well, I have the summation from I is equal to 1 to n of 6. That doesn't change. But my I over 9 does, plus 4. All right, see you later.